All right, just a little quick extension of solids. A cross section is when you have sliced through an object and you're looking at what's inside of it, or particularly the shape. This is used a lot in the medical field. It's the cross section of a what? What do you think that is? Not a lung, it's a kidney. Okay, cool beans. All right. And that's a shoe, of course. Seeing how thick they are, not very good. I would think that would hurt my foot because it's not very cushiony right there. All right. Next, a helicopter and all the little parts up inside of it, and even some people getting rescued. So cool. All right. So when we do just geometry shapes, when you take a cross section of a cone, you get a circle. If you cut it that way, it all depends on which direction you're cutting it. Notice that this is parallel to that base and it matches. That's the whole key right there. If it's parallel to that base, it's going to match that base. It may be the same size or it might be a smaller size. Look at the cylinder. When you cut it parallel to the base, see, here's the base. It's parallel, it's a perfect match. But on a cylinder, a cone, and on a cone and a pyramid, the match gets smaller and smaller as they go up. So if I had a little cross section there, it'd be real tiny, but it still matches the shape of the base. Okay, when you do cylinders and prisms, they'll have the same size as the base if they matched it. So think of it being sliced in half, what you see on the inside. So here's a little quick thing you can read over. That's the answer. Alright, so slice a piece and it creates a new cross section. Cross sections can be taken horizontally or vertically or parallel or perpendicular to the base, depending on which way your base is turned, but they can also be taken diagonally as well, so you just have to be careful. Notice right here, when you slice it like that, you're doing one that is perpendicular to the base. Okay, notice when you open it up, here it is, it's not matching the base. It has really nothing to do with the base, it's more parallel to the sides. It's going to be a rectangle. Alright, so when it's parallel to the bases, it's going to match the bases. Look at it. Whatever it's parallel to, it's more or less going to match that part. Parallel to the bases matches the bases. The cross section is the same shape as the base. Alright, but if it's perpendicular to the base, it's more matching the sides. So these sides, remember how we talked about a soup can? If you unroll it, the label on it is a rectangle. Well, that's what you get when you look at a cross section perpendicular to the base. Same thing with a cone, perpendicular to the base. What do you think you're going to get right up in here? Up in there when you slice it open and hold it open? A triangle. A little bit more like the sides than the base. Alright, parallel to a cylinder, you get a cone. Parallel to, this is a perpendicular to the cylinder. Look at it, more like the can. You're going to get that rectangle up inside of there. You sliced it like that. Alright, parallel to the base of a pyramid. You see it? It's a square. It's going to match. Kind of perpendicular. I mean, kind of looks more like a parallelogram right there, but it's still, if that's a square-based pyramid from the side, then you get a square. But when you got it perpendicular to the base, standing straight up on top of the base, you end up with a triangle. That slice is going to look like a triangle across there. Okay, triangular prism. If it's parallel to the base, it's going to match the base. If it's perpendicular, see, this will be a right angle coming out that way, then it's going to more or less match the sides, those lateral faces. All right, so we get what? Parallel to the bases, you're going to get a pentagon. I don't know what's happening here. I don't think that thing's kind of weird looking. Across the base, you're standing it up right there. It would end up being a rectangle, not a hexagon. Now this was diagonal, and so diagonals can hit all kinds of different ways. And maybe we'll show these in class with the sand modules that I have. Lets you show what happens with a diagonal hit. Alright, this one is used a lot in calculus, some trig. A circle, of course, is the parallel, but what if it's diagonal? You get that ellipse showing. And you also could have a hyperbole where it kind of makes an arc like that. Sphere, you just get circles. Nothing to it, nothing else, because everywhere you turn the sphere, it looks the same.